All right, this is take like 10, 15. I was trying to record my PowerPoint screen while I talk to you about my lecture review. So kind of forgive the fact the quality is really crappy. I'm doing it off my phone because I can't get it to work. All right, let's move forward. What was the lecture about? Well, this lecture was about the physics of food. I love food. I like physics. So let's combine the two. Should be interesting, right? Well, let's see what we learned. So we learned about coffee. Those rings that you see all over the tables after you've had coffee, yeah, we worked on those. How do they form? And why are the outsides of the ring darker than the insides? We also learned about scrambled eggs. How do they go from the liquid form to the fluffy goodness that we know and love? Yeah, my idea of why it did that, at least originally, was not correct. And I actually really like this one because it has a lot to do with my majors of BME, so we'll get back to that. Then Cheerios, why do they clump? Let's find out. So the coffee rings. So I always assumed that the coffee rings were because of the fact that if you have a coffee cup and most of them have that like little raised bottom circle, so they don't like sit flat, I always just assumed that raised bottom circle is why the outsides of the ring were darker. It was just where it built up more. Actually, it's because there's particles in the liquid, and these particles build up as the liquid tries to spread. This is why the outside of the rings are darker, which is interesting because, it's not really something you think about, but it makes sense. Like, as the coffee, tries to spread, the more particles go to the outside, eventually they make this little wall. All right, not my favorite one. Moving on. Eggs. All right, so my initial thought was that the liquid in the eggs was evaporating, and it was just like leaving the solid portions and the proteins and whatnot. So I learned about this last year in cell physiology and BME, and it has a lot to do with proteins. As the eggs are heated, you're actually basically deteriorating the proteins, and you're making them change form. So as they deteriorate, they lose their very intricate form that allows them to be all liquidy and whatnot, and you're left with the wonderful fluffiness that we have now. Proteins are really interesting and very complicated creatures. I guess they're not creatures, but as a BME, I was really happy that you did this one. I wish you had done some more other than just scrambled eggs, but it is what it is. Alright, so next, what did we learn? So the Cheerios. This section I didn't get a lot out of. A lot of people were talking because we were coming up on the end of the lecture, people were leaving. I think I missed a couple of key pieces of information. I heard him talking about meniscus, but I didn't really catch it. So I'm going to kind of give you my idea of why the Cheerios clump. So the milk doesn't want to hold up the Cheerios. It doesn't. And it takes more energy for the milk to hold up the Cheerios separately than it does when they're together. When they're together, they share a side, and the total surface area that the milk is having to hold up decreases. So I really think that this is more of the reason why the Cheerios clump. I could be wrong. This is really just my idea on the whole situation since I didn't catch this part of the lecture. Alright, so what did I think? Overall, it was a pretty interesting lecture. Like I said, I really like food. Physics behind food is pretty cool. I wish he had done more examples. I wish he had done more of a, the physics behind cooking the perfect egg. Things like that you can, go home and try kind of thing would have been really cool instead of just explaining, a few things that we see. But other than that, it was a pretty successful lecture. I'm really glad I went. And that's it. That's my video review. Thanks for watching.